Hello everyone, this is Aida Gholami from Agreement Soft Research Company, and in today's video we are going to talk about Way Anova in Excel. So before we start, I wanted to add that this topic is so much interesting to me, and I had a lot of fun for studying in order to get ready for recording the video, and I'm so passionate about this topic, ANOVA and Way Anova, and playing with Excel and this type of things, and I hope you enjoy also, and I hope you just get it nice and easy. So let's continue. First of all, I want to start the video by an example or by introducing a problem. Let's say we want to estimate the home price. So we have home price, and we want to estimate the price of the house using two variables. First is the area, and the second is the number of rooms. So we have area and number of rooms for estimating the home price. Then we know that we have two categories for area. So we want to see how does area more than 500 square meters and more than 700 square meters impact the home price. And we want to know how does the number of rooms, let's say if it has 2 rooms, or let's say it has 4 rooms, how does the number of rooms in this type impact the home price? Or at least we want to know that if these two factors basically impact the price or not. So that's what we are going to study. We want to study whether the area or the number of rooms of a house impact its price or not. Obviously, we have a very simple example in here so that you can relate to it and you can understand. So what we have in here is a table. Okay, so we have 2 rooms and 4 rooms, and then we have 500 square meters and 700 square meters. Okay, then we want to make something like this. So we have the numbers for 2 rooms and 500 meters in here. These are the numbers. And then we have for 4 rooms and 500 meters in here. These are the numbers. And again, for 700 meters, 2 rooms and 4 rooms. Okay, so that's the table, and that's what we are going to study. With this introduction, I want to jump into the video. Okay, so basically I want to inform you what is ANOVA. If you have watched my previous video about ANOVA, which was Way Anova in Excel, you know this type of things. But for you who have not watched that, I will make a quick review in here. So ANOVA basically wants to study the react of the variances to factors. So we want to see how does the independent variables impact the dependent one, or how does these independent variables, how does the dependent variable react due to independent ones. When we say one way ANOVA, we are studying just one factor. Okay, so if we have just one factor, then we have one way ANOVA. And if we have two factors, then we have two-way ANOVA. Each of these factors have some levels. So like this, we have a factor named the number of rooms, and then the levels in here is 2 rooms and 4 rooms. We have another factor named the area, and the levels in here is 500 square meter and 700 square meter. So that's the level for the area, and that's the levels for the number of rooms. That's it. So now that we are familiar with those type of things, let's get into the Excel file, and let's get into Excel and run the test, and then we will see how to interpret the results. So in here, as I drew the table, maybe my table was oriented a little bit, okay, so but there's no, there's no problem and there's no difference. And in here I have another table for that. So I have 500 square meter and 700 square meter, and this data is for 1 room and 500, and this data is for 2 room 500. This is for 1 room 700 and 2 room 700. Okay, what we're going to do is to go for data analysis in analysis tab. If you don't see it right there, go to file, more, options, and in add-ins, click in manage Excel add-ins, click go, and here check the analysis toolpak and click OK. So I will click on data analysis, and here is what I want: ANOVA 2-factor with replication. But we have 2 options in here, with replications and without replication. You want to go for with replication. It means that for each of these cells, for 500 and 1 room, you have more than one observation. But without replication, you have just one observation. Okay, so I go for with replication. I click OK, and then I go for input range, which is the selected area, rows per sample. So what number of rows do I have in here? 1, 2, 3, and 4. So it's 4. Then alpha for me is 5%, which is okay. And then output options, which you can choose the output range. So I wanted to start from here, and it's okay. I click OK, and then you can see these tables, these output tables are now produced for me. Okay, so let's get started from the top. ANOVA 2-factor with replication, which is the title, and then we have some tables for summary. So that's the simple summary of your data. You have 500 square meter and 700 square meter. First table is for 500. You can see the count, which is the number of data for 1 room and 500 square meter, which is 4. You have 4. Okay, Of course, for 2 room, you again have 4, and then the total is 8. The sum is the normal sum. So you have sum of this data, which is this one, and then you have the sum for this data, which is in here, and then the total. Then you have the average. So that's again the normal average. So you have this one for this and this number for 1 room and 500. Okay, then you get to variance. So this is again the normal variance of sample. So you can see this is the variance of sample for 500 1 room, and then again for 2 room. Then you have the total, which is the whole range, okay, from B to, that's the whole range. Then we get to 700 meter, which is the exact same thing. You have another summary table for 700, and then you have for total range. Okay, so that's the sum, average, and variance for the whole ranges for 1 room and 2 room. Okay, if I have another shape of table which I had in here, okay, these this variance or average, which you can see the total of 8 in here, is for room. If I had the other shape, it was for 500 meter. Okay, so it was maybe this part, but now is this part. So let's get into the ANOVA table. You can see the source of variation, SS, which is the sum of squares, DF, which is degree of freedom, MS, which is mean of squares, F, which is the F statistic, and then p-value, and then F critical. And then you have the total for these 2 columns. Now you can see in here source of variation for sample, columns, interaction, and within. So in ANOVA, what we want to study is the variances within each group. So it's for within each group, and then the between the groups or the interactions. So we want to see if the area impacts the number of rooms. So that's for interaction. It can affect each other. Okay? And within each group, interaction, columns, which my columns in here is 1 room and 2 room, and then the sample, which is 500 square and 700 square. Okay, so let's get into the formulas. So how does Excel calculate these terms in here? So we have the sum of squares for columns and samples, which I said columns is rooms, samples is the other factor, which is the area. Okay, so another way to interpret is, let's say columns is factor A, and then sample is factor B, which factor B is area and factor A is number of rooms. Okay, So let's get into here. Now Excel goes for these calculations as this. So it has sum of squares for factor A, which is something like this: Bn sigma j from 1 to the number of levels of factor A, which I say A, for x bar j subtracting x bar from it, power of 2, and then degree of freedom in here is a minus 1. Okay, so sum of squares for factor A is B. What is B? B is the number of levels for factor B. Okay, so what we had in here was something like this. Okay, so we had first level of factor A, second level of factor A, first level of factor B, and second level of factor B. B is the number of factors, so this is for A, let's say, and this is for B. So this is the number of levels for factor B, which is 2. N is the number of number of data that you have for factor A. That's N. And then sigma j from 1 to A, which is the number of levels of factor A, which is 2. In here we have x bar j, which is average of data that we have in the first level of factor 1 of factor A, and then another data that we have in the next level and to the end. Okay, so j is from 1 to the level of A, and then we subtract x bar of all data from it. Then we get it to the power 2, and degree of freedom in here is the number of levels for factor A minus 1, which is 1 in here. Okay, so then let's get into the Excel file. So we had SS for factor A, which is here, and we saw how does this number produce. Now we want to have the SS, or sum of squares, for factor B. So the formula in here is also the same and so easy. So it's SS for factor B is A multiplied by N sigma K from 1 to the number of levels of B, and then x bar K minus x bar power 2, and degree of freedom in here is B minus 1. So another time we have this table. We have 2 levels for B, so that's 1, 2 for factor A and 1, 2 for factor B. And then in here we want to calculate sum of squares. sum of squares for factor b. Then it's number of levels of factor a, which is 2 multiplied by the number of observations in factor b, and then call from 1 to the number of levels of factor b, x bar k, which is in here, the x bar for level 1, and then for level 2, minus x bar of all the observations, power 2, and then degree of freedom is number of levels minus 1, which is in here 1. So we just reviewed the formulas for all these, and then we have the interaction and within. So sum of squares for the interaction has the formula like this. So we have the sum of squares for interaction of A and B is k from 1 to number of levels of B, and J from 1 to levels of A, and x bar for kj minus x bar of k minus x bar of j minus the whole average, power 2, and then degree of freedom in here is a minus 1 to b minus 1. So in here also is, I think, obvious. We have levels of A, levels of B, 1 and 2, 1 and 2, and then x bar of kj in here is x bar of the cell. So k for so each cell, okay, each cell minus the x bar of k. So k was for levels of B, so each cell minus the first level minus the x bar of each level of A minus the whole average, and we do it for all levels of A and B. And the degree of freedom in here is 1, because 2 minus 1 multiplied by 2 minus 1 is 1. And then we have the within. So for within, sum of squares, another time we get to the formulas. In here, what we have is sum of squares of within groups, which is k from 1 to levels, j from 1 to levels, and then I from 1 to individuals. Okay, and what we calculate is x, I, j, k, which is each individual. Okay, so it's each individual minus x, j, k bar, power 2, and then degree of freedom in here is n minus A, B multiplied by each other. Okay, so in here also it's so obvious. We have to subtract the table. Okay, we have to subtract each cell average from each individual in each of these cells, and then we get to power 2 and we do it for all levels and all individuals, and then degree of freedom is also obvious. So that was for within, and then the total sum of the squares is so much similar to within sum of the squares, and the difference is that in here, instead of x bar jk, we have the whole x bar, so we have the average of all individuals. Okay, so then the degree of freedom is n minus 1 for the total sum of the squares. Okay, so now that we have studied the formulas, we also know that mean of squares is result of sum of squares divided by degree of freedom. Then we get mean of squares. And then for f statistic, we have to divide mean of squares for each factor to the mean of squares for within. Okay, so we have the f statistic in here, and we can divide this one by this one to get the first one, and then we can divide the second one by the within to get the next, and then the next. So, and then we have the p-value related to this f statistic, and all we have to do for decision making is by this p-value. So what does it tell us? So p-value, we know a main rule, which is if p-value is bigger than alpha, it means that the result is insignificant. So if, for example, if you want to see if one factor has an impact on the dependent variable and you get a p-value higher than alpha, you can make decision that this factor does not have a significant effect on the dependent variable. But if the p-value is lower than alpha, then you could decide that there is a significant impact. Okay, so all we have to do now is to compare the p-value to the alpha in here, which is 5%. So let's get into it. We have p-value of 4.1, and look at those numbers. So this is so low. Okay, so we have, let's say I want to change the format so that you can see the zeros. Okay, so that's our numbers. So these are so much smaller than our alpha, which is 5%. So we can decide for the first one, which is factor B, which is area, we can decide that area has significant impact on the price of the house. And then we get p-value of also too much low for number of rooms. So another decision, number of rooms have significant impact on determining the price of the house. And then also there is a p-value too low for interaction. What does it tell us? It tells us that these two relate to each other. So maybe if the area is so much low, the number of rooms also are so much low. Or if the area is bigger, then you have more rooms in the house, so they can affect each other. Okay, they can impact each other. That's what p-value, low p-value for interaction tells us. So I guess that's it for today's video. I hope you learned something new. If you want to know more about Way Anova in Excel, please don't forget to watch my previous video about Anova, and it has also some informations maybe useful for you. And then that was my test in here, and that was the analysis of variance, two-way analysis of variance, and the interpretation of the tables. So I guess that's it for today's video. I hope you learned something new. Please don't forget to give this video a thumbs up and subscribe to the channel. I will see you in the next video, and bye.